Welcome everybody to the Sheehan event on big data. My name is Sheehan and I'm your host for the evening. You're joining us at quite an exciting time for Sheehan because we're going to be 10 years old next week, so happy birthday to us. The rest of the Sheehan team are surrounding you. They're all in the blue ones of these, and they're probably dressed pretty much like you guys because we don't really go for the sharp suits and the ties these days. So say hello if they're anywhere near you. We've got two great guys in Andy and Dave who have volunteered to give theirs and their company's experiences around big data from two very different worlds. Andy Doan is the data platform lead for King. Dave Ellerman, who heads up the tech consulting at ThoughtWorks, specializing in machine learning, big data, and scaling solutions via the cloud. ThoughtWorks, obviously, a global leader, global tech company, over 2,500 people in 29 different countries, and probably counting, Dave, isn't it? Big data is getting a lot of press at the moment, and I think it's safe to say that most of us in the room have probably seen or heard the joke about big data being like teenage sex. Everyone is talking about it, but nobody really knows what to do with it. From purely a recruitment point of view, in terms of actually a skill set, what a lot of clients and a lot of companies are looking for, I haven't seen something quite as explosive a skill set as the word agile came about in London in 2001. And it's surprising to us, like agile, it's incredible how many people have suddenly got big data on their CVs when actually it's very hard to find these people. We're going to have a slightly different format from previous events. Unlike a break in between, we're going to have one presentation after the other, and we're going to have a Q&A session after each presentation. However, what I would say is, if you don't get time to ask your question, grab these guys afterwards, because you will not find two more engaging guys. So after all that, I'm handing over to Andy. Andy, over to you, mate.
Good evening, everybody. Thanks, John, for that warm welcome, and thanks for hyping me in the same way as people are hyping big data. I'm Andy Doan, it's true, and I am the data platform lead at King. What I want to do today is really tell you a story, and tell you a story of King, a story of our data, our big data, and our architecture and our platform, how it was a few years ago, where it is now, and the lessons, mistakes we learnt along the way, and share those with you today. So I want to start just by looking at this big data concept. What is that? I think we all have an instinctive idea what it is, but let's unpack that phrase and try and get some more detail. I want to talk a bit about King, so paint the picture of who we are as a company, what we do, and why we do it. And then talk about specifically our data and our data problems and how we've solved them. Where next is always an interesting one. So I want to share with you where we think our platform's going the next 12 months or so, and the challenges we face, and what we're imagining we're going to do about them. I'll take some questions then. So, what is big data? So Gartner, I believe, come up with this 3 V's concept to describe what is the sort of amorphous blob that we all know as big data. They describe big data as having 3 characteristics: volume, velocity, and variety. So that's good, because that's an acknowledgement that this big data word has some dimensions, it has some qualities, it's more than just a slogan. But this immediately gets you into problems. What if you've got a project with massive volume, a huge variety of data, but it actually arrives quite slowly, maybe once a day, in a bunch of hard disks in the back of a truck? Does that mean you don't have a big data problem? Who knows? Some people are even talking about the 4 V's. They've added veracity. to this concoction, which I had to look up. It's not veracity. Veracity means kind of truth or accuracy in data, and I kind of hope that there's an element of that in most data projects, but maybe I'm just being idealistic. So we stand here, we make a declaration, our data is big. So I realized now, thinking about it, that it was my junior school English teacher that actually equipped me with the tools to stand in front of you today and explain this a little bit. So we were like 7 years old or something. I just come back from summer holidays, and our class teacher gave us a project to do. I said, write a short piece about your summer holidays. Great, that seems pretty easy. Here's the catch. You can't use the word big. So this was kind of a problem for a bunch of kids whose big was their primary adjective. We didn't have many other tools in our belt. You know, we went, took a big drive to the beach. The waves were big. I ate a big ice cream. I rode on a donkey. It was big. I drove home and had a big sleep. Yeah, that's not very useful. So if you say the same thing about your data, say our data is big, well, it's not just big. It is lots of things. I think it's much more helpful to acknowledge that and dig into your data and start asking those questions. So what qualities does your data have? What characteristics does it have? Because in acknowledging that, you acknowledge that there may be more than one way to solve your big data problem, and there may be more than one tool, sorry, with which to do so. So that's the stage. How about King? Let me just explain who we are, a bit about our history. So we were founded in 2003 in Stockholm. We just celebrated our 10-year anniversary. Yeah, the game, the original business was a skill gaming site called MinusPlayer.com where you could play puzzle games and challenge people. If you wanted to make money, you could put a wager. The other girl could put a wager. The winner would take most of it. The house would take a bit. So that was the kind of business model. So they sensibly rebranded to King.com a short time after. But success really only came when we took one of those skill games and tried it on this thing called Facebook that everyone was talking about. That turned out to be pretty successful. But the growth really took off when we took another of those games and put it on mobile, and that's where King really saw sort of explosive growth in the business and led us to the data problem that we're going to talk about today. There's some of our games. You may have heard of Candy Crush, which is probably our most popular one right now. We're sort of a little bit special as we've got presence on the web, on social, and on mobile. And the unique thing about King games is that you can play a King game on Facebook Connect, and then if you pick up that same game on your mobile, your progress is synchronized, so you don't lose your position, your lives, your magic Smurf berries, or whatever you've collected. Some numbers just to kind of get some boundaries on what we're talking about. So as John already said, we've got about 100 million daily active users. And they collectively play about 1 billion kind of rounds, goes at our games each day. We're in 8 locations across North America, Europe. And let's look at the data. So we get about 14 billion rows of data new each day, 14 billion events. That's people playing the games and doing stuff and interacting with them. Compressed, that's about 500 gigabytes of data per day new, and we've got a historic storage of about 700 terabytes. So for the techies in the room, there's some sort of numbers to get excited about. So let's look at, I said we need to unpack this word big. So let's look at our data with those eyes and see what we find. What can we say about our data? Well, our data certainly is growing. This is a graph of our data ingested each day, starting in 2011. This is the growth rate, and this is when we went onto mobile. So you see things just took off astronomically, and that gave us what people in the industry call a scaling problem. To solve scaling problems, one thing you can do is reach into your bag of tricks and look at Hadoop. So Hadoop is a very scalable system. And actually, back in the day, we're still a ClickView shop, by the way. We use that for our BI layer. But we used to actually do all our data processing in ClickView as well. And at some point, that gave up. We deployed a community edition of Infobright. Some of you might know that, a MySQL engine database. And eventually that also gave up the fight as well. That's the point we introduced Hadoop. We've been scaling that from 10, 20, 40, 80 nodes where we are today. So we tackled our initial scaling problem with Hadoop, and that worked pretty well. Another observation of our data, it's not actually that useful in its raw form. This is true for a huge many of data projects and companies, I know. So let me give you a sneak peek. That is what our data looks like when it arrives with my team for processing. What's happened here? Give gold to user. That's a lucky user there. We've got timestamps, we've got dates, some strings, some numbers in there, but that's the story we get back from the games. So to make real use of that and generate real value from it, we needed to process it, and this is, roughly speaking, how we tackle that problem. So our game servers write out these log files, which we stage on a log server and load into our data warehouse. So the raw data then, through our ETL process, gets transformed into a dimensional model, which will be familiar to many of you who've worked in data warehousing. The raw data and that dimensional model are available for use by our data scientists, users, and for building reports. So what's so great about a dimensional model? Why do we bother to build that? Well, it transforms your data into a form that's much easier for end users to take advantage of and use. It's much more friendlier. It gives you a flexible framework, a scaffolding where to hang elements of your data and make them easily understandable and discoverable. The data warehousing industry, dimensional modeling, that's 20, 30-year-old industry. So there's a huge reservoir, a huge bag of techniques and tricks that have been worked on throughout those 20, 30 years. So if you've got a problem, it's very likely that someone will have already solved that once upon a time. It also provides a nice way of structuring your thinking, structuring the way you think about your business and the way you conceptualize the data within it. So let's look at both those things now, so our raw data and our dimensional model. So they're both actually quite well structured. As I said, our source data is kind of tab-separated column data, and our dimensional model itself is well structured. It's tables, it would fit well in a database. And that got us thinking, because we're appreciating the strengths of Hadoop, the scalability, the resiliency. You can lose machines, you can lose disks. We lost a whole rack once, and it was fine. It's a very flexible system, and it gives you very low cost but accessible storage. The alternative would be put that huge amount of data on tapes or a SAN somewhere, and maybe you never see it again. But with Hadoop, you have an efficient processing framework that you can use to get at that data. And it's also very good at unstructured and semi-structured data types, so things like images, PDFs, stuff that isn't kind of columns of numbers and that kind of stuff. But there's some weaknesses too. So working over that structured data, the performance in Hadoop actually isn't that good. It's often not that easy to use. And it requires quite a lot of maintenance, care, and feeding, so you need a reasonably skilled people to make that thing work for you. But what's really lacking is fast data exploration. If you're a data scientist or a business user, you want to kind of pop open a table, have a little look in there, sort of count some columns, see the distinct values in something. Just kind of fast slice and dice stuff to get a feel for your data, and that is quite difficult to do in Hadoop. Joins, which is bringing two tables together, that is also quite challenging for the processing framework MapReduce that runs on top of Hadoop. It's not a very natural operation to do there. And unfortunately, it's something you do quite a lot of if you've built your data into a dimensional model. So we thought a little bit about that, and this is basically what we had at the beginning, the data coming in to Hadoop, Hive, that's the SQL-like layer that sits on top of Hadoop, which we used. And we do all our transformation there, our data scientists did their work there, and we built our reports out of there. So what we got to thinking was, what if we paired that with some kind of analytics database? We could possibly get the best of both worlds, so that's what we set about trying to do. So why would we bother doing this thing? What are the potential benefits of such a database? So we were hoping it'd be more optimized for working on that kind of structured data. So our dimensional model, I said we got about 700 terabytes stored. That boils down to about 50 terabytes by the time you've processed it into the dimensional model. That was what's useful to us. So we were hoping we could load that thing into a database. We were hoping we would get the fast data exploration, that slice and dice, that discovery that we've been looking for, and providing a more friendly and productive environment for our users. Hopefully their queries would run faster and they would get really happy and buy us gifts or something. So that was a sketch we had earlier showing our data growth and what we had with Hadoop. So we started some projects to explore the analytics database world. We first deployed a database called InfiniDB. That's another of those engines for MySQL, which actually worked pretty well. But at some point, the data volume just got too much for it, and we were forced to go back to the market and look for something different. In the end, we settled for a database called Exasolution from a German company, Exasol. We did a full POC of that with a competitor's product, and we really liked what we found, so we deployed Exasolution into our architecture. Just a little bit more detail on that. So why did we choose Exasolution over a competing product? So we found for our use case it to be exceptionally fast. We were really pleased with that. And very efficient. So on relatively modest hardware, you can get really good performance, and that was important to us. It has a kind of tuning-free approach. So a lot of you have worked with databases. You spend a lot of time hinting and tweaking and tuning and optimizing and partitioning stuff. So Exasolution does that for you, which we really appreciated. And we found it to be very scalable, so we've got about 50 terabytes in there right now, and that's growing. Vendor selection is really important if you're doing stuff at the edges of the big data landscape. And we found Exasol, the company that makes this database, to be very good to work with, and we found a lot of commonality between King and Exasol, so that was turned out to be a really good partnership. So let's just look at some numbers here and compare these two worlds, the Hadoop and the database world. So if you look at performance by price, so how much performance do you get if you're going to spend $1 or more? So if you compare something like Exasolution to Hive for working with this structured data, what you find is that the Exasolution was, I don't know what that is, about 20 odd times better value for money in terms of performance price than trying to do that workload in Hadoop. Just to put that sort of in pictures for you, we found that about 4 Exasolution nodes to get the same performance in Hadoop for that structured data, we would have needed to deploy over 400 Hadoop nodes. That sounds great, but there's another flip side to that. Let's look at the price per terabyte of usable storage. I say usable storage because in Hadoop world and in scalable databases, there's often redundancy, multiple copies of the data, so I'm talking about actual what you can really store here. If you try and store that on database grade servers, so reasonably high-end machines with nice fast disks, that's going to cost you about for us, about 7 to 8 times more than trying to store that in Hadoop-grade servers, which are cheaper, commodity machines. You can use bigger, slower disks. So what's the point of all this? Well, the point is that there's 2 very different use cases there. What we're trying to do is get the best of both worlds. We want that scalable, resilient, flexible, low-cost storage system that Hadoop gives us, but we also want really good performance over our structured data. We want it to be easy to use, low maintenance, to explore our data quickly and do things like joins efficiently. And that's what the database gives us. So that's what our data platform 2.0 looks like now. So we've got Hadoop, we've got Xsolution, that's actually where we're doing our ETL now. That's where we get our reports from, and our data scientists are free to go to either environment, depending on what their needs are. So, where next? Big challenges we're currently facing, certainly keeping on scaling. Fingers crossed, we still enjoy good growth. So that's going to be an ever-present challenge for us. There's a lot of technology innovation happening in this space. So in the Hadoop land, there's a lot of exciting stuff happening. The database vendors are also innovating a lot. There's exciting things happening there, and you see a lot of convergence happening. So we've got to keep up with that. We've got to keep flexible. We've got to keep an open, flexible architecture that allows us to take advantage of these innovations as they happen. King's business is growing, our world is evolving, it's getting more complex, so our data model, that dimensional data model I was talking about earlier, has to evolve to keep up too. Currently we process all our data daily, so we do a big daily crunch, which is fine, but what we would like to do actually is start moving that to maybe hourly, maybe less. So taking what they call micro-batch ETL approach, so nibbling away at your data throughout the day. And ultimately, of course, where that ends up is talking about realer time. So these are some pretty big, interesting challenges we've got in the year ahead. I want to just talk a little bit more specifically around this kind of micro-batch and real-time space, and I think Dave's going to pick up some of these ideas later on. So just to recap, that's where we would possibly like to be in the next 6 months. So actually loading our data instead of into Hadoop directly, getting our really valuable data as quickly as possible into the fastest system we have, which is currently Xsolution. So let's just look at what our sort of 4.0 platform might look like. So here's the data arriving kind of now. And as you work on it more, as you process it more, you improve the quality, you improve the context, but it takes time, so you increase the latency. This is where we are today, doing daily processing in our database with a kind of batch approach. Maybe we want to start moving that line a little bit closer. We want to move to hourly. 15 minutes possibly with a micro-batch approach, and we're closing this gap here. So I have termed that gap there the Latency Canyon. So that's the gap essentially between now and when your data processing system picks up. So if you want to do stuff with a few milliseconds latency, let's say a couple of 100 milliseconds for some kind of application, you've got some other system that needs to fill this space. So how can we bridge that canyon? So this is what the real-time systems that we were looking at are going to fill. So we've got several teams in King looking at the real-time problem. My job is to try and bring this line as far this way as I can to help them out, so they have to do less work and they can take advantage of all the processing, the quality and the context that we've added to our data at this side of the picture. Just to wrap up then and conclude. So behind big data lies many diverse requirements. So rather than labeling everything with this phrase big data, I think it's helpful to start unpicking that, look in detail at the qualities your data has, and look at the unique problems your data might have, and solve them in specific ways. So despite what all the vendors might want to tell you, there is currently not one good tool for that job. Maybe there will be one in 3-5 years, I don't know. But right now, I believe that hybrid architectures give you the best of more worlds, and whether that hybrid architecture is Hadoop plus a database plus a real-time system or some other combination, I think that is currently the only way we see to solve all these problems simultaneously. So thank you very much for listening. Appreciate your attention. I should say that we are hiring, so if any of that stuff sounds interesting to you, we'd be glad to speak with you. We're hiring across data science, data warehouse, platform model, real-time, the whole shebang, obviously with help from Sheehan, much appreciated. Yeah, I'll be very happy to take any questions now.
Go for it. Can I just say this is a big data event, so just in case someone wants to know, like I do, how you get past level 188 on Candy Crush, and it actually doesn't know, so if they're sort of big data relevant. We've got a roaming mic there. Yeah, so if we start over here, perfect.
Hi.
Hey.
I was wondering, what about 285 anyway? Do you use, which version, distribution of Hadoop do you use, and have you considered Impala? Thank you.
Yeah, you keep that one and I keep this one, right?
Yeah.
So yeah, the question, what distribution of Hadoop do we use? Have we considered Impala? So we use the Cloudera Hadoop distribution. We're not on the latest and greatest version right now. So that's a project we'll probably take on this year, is to kind of bring that the cluster up to a more recent version. I think projects like Impala and the other kind of SQL on Hadoop systems are very interesting. I think they're maturing fast, they're growing fast. We don't think it's ready for production deployment yet. One of what I can see in the future is that we might deploy a SQL on Hadoop solution like Impala to our Hadoop cluster to help with our read-only workloads. But one of the big challenges which remains to be solved in the Hadoop space is things like update and insert and merge semantics, which are really essential if you're trying to do ETL, but are very tricky to do in Hadoop land. It's not to say it's impossible, but you'll experience, experience some challenges doing that. So yeah, I'm excited to see what innovations happen on both sides of the camp, and so we'd like to be able to take advantage of any of them.
Okay. What I would like to ask is that regarding your quest to go onto the real-time path, did you consider looking into the Amazon Velocity implementation, or even in-house or something like that? Because I think this is something along those lines what you are trying to implement right now. More generally, kind of loads of things what you are talking about, the things that like you're kind of targeted in the cloud space anyway, one provider or the other. So I just wonder if you looked into this solution, or at least looked at your problem from this angle.
So the question was if we're looking at things like Amazon Velocity, but as an in-house solution. And that's it. Yeah, sure. So that's a good point. So just for clarification, so King, we host all our data ourselves. We run our own data centers, so we don't have any cloud solution. So we have teams looking at the real-time problem. Right now, we structure our solution around the Kafka project, Apache Kafka. So that's our real-time event queue. We're currently doing R&D projects to look at the various ways that you could take data off a Kafka stream and process it in real time, and how all these pieces fit together. So as I was saying, the huge value you've created on the right of that picture with your dimensional model, it'd be fantastic to somehow be able to expose that to a real-time system in a meaningful way, so that it has to do less work and can take advantage of all that, all that pre-processing that's happened.
I only ask because these big cloud providers usually provide on the implementation for the solution. So just like I wonder if you can, probably depending on the scale and how much it costs. So it's, I don't know.
Yeah, exactly. I think real time, more so than almost anywhere else in that picture, is the area where you really, really need to focus on your requirements. Because if you try and just make everything real time, then it becomes a hugely expensive and probably futile exercise. So I think real time is very much about looking at specific use cases and solving them in specialist ways. I'm sure in coming years there'll be a lot of innovation in that space, and maybe we will have a kind of solution that fits neatly into that gap. Right now there's a whole bunch of contenders, and yeah, we're actively looking at several.
Hi, over here. I was interested in what you said about the data model evolving.
Yeah.
Particularly because I picked up on the fact that you are generating your own data right now, presumably because I assume you're not using any tracking solution like GA or anything like that for any of your...
No, we are the tracking solution.
So you generate your own data.
Yeah.
So how are you currently dealing with that challenge of the evolving sort of data model or the schema in your solution?
Yeah, so some of the, so it's a good point to mention that you think we have our own games, we run our own data platform, what kind of mismatch could there be there? So there was always some kind of tension between the systems producing the data and the most convenient way to produce the data and the most convenient way for us to consume it. So that's always something of a compromise. We try and make sure that it's designed well for both of us, but often we can't achieve that. So we've got specific problems around, for example, identifiers, which are really hard in mobile. So iOS 7, for example, release changed the way that Apple devices identify themselves. So for us, when we're trying to understand player behavior, and when IDs in the real world are changing, keeping the linkage between IDs and understanding that and presenting that in a way that a business user or a data scientist doesn't have to worry about it is kind of interesting. And we try to solve that problem in our dimensional model using fairly traditional dimensional modeling techniques with durable keys and all this kind of stuff.
Slowly changing dimensions.
Right, exactly. So our problem is that our dimensions are so large. We have billions of rows in our dimension tables and hundreds of billions in our fact tables. So doing slowly changing anything is kind of tricky. So we have to make a really strong case for that kind of explosion that would happen as a result of that. But yeah, these are really interesting problems. We lean heavily on the kind of techniques from the traditional dimensional modeling world. We're learning about a lot of that too. So it's challenging. Yeah.
Thank you.
Thanks very much.
Probably take one more. Anybody got over there? Perfect.
Yes, hi. Andy, a lot of the data you're talking about at the moment is structured data.
For us, yes.
Yeah, on the roadmap for King, do you foresee products or services or games that you will need to capture unstructured data and actually do analysis in semi-real time in that way?
Yeah, so the first question, I guess, is do we see unstructured data coming to the business that we want to make use of? And then I guess you're poking me with another real-time question about doing that whole piece in real time as well. So we don't currently have a strong use case for processing that data into our data warehouse. If we're doing things like sentiment analysis, then that's generally handled by some kind of third-party system. We look at aggregated results back. So it is a very interesting problem space, which we don't yet have a compelling use case for in-house. I would love to be at the meeting where we decide that we not only need to do that, but do it in real time, because I think that would be a very terrifying but exciting discussion. Yes, nothing really concrete on that in-house yet. Thanks a lot.
Thanks, Andy. Thanks very much.